Hello everyone, and let us continue our discussion on database management systems. So till now we have discussed a lot of things about entity relationship model. So we discussed about its component, we understood how to represent each component, what is the convention, we spoke about the drawbacks of basic ER model, then we understood about the features of extended ER model. So basically, till now we were talking about the theoretical part of entity relationship model. Now let us take a step ahead and talk about drawing an entity relationship diagram. So this is where you actually implement whatever knowledge you have from the theoretical section. So this video is going to be very important because no one is going to come and ask you about the definitions or what is an ER diagram. So people are going to come and ask you to draw something. They're going to give you a situation and you have to draw the ER diagram for that particular case. So kindly pay your attention because this is going to be very important video. So let us move ahead and let's begin step by step. Let's understand what are the steps to make an ER diagram. So if you're given a case, like if you're given a scenario that you have a case situation of your database, what is the first thing which comes to your mind? I think you need to analyze whatever is there inside. So you begin with identifying what are the real objects, what are the key focus points about which you're going to store your data. So the first thing is identifying the entities. You will be identifying the real objects or concepts which you're going to need, like the focus points, right? So let's write the first step. It is identifying all entities. Now you have all the entities in your dataset. So next step would be to define these entities. Now what defines these entities? You need to have some properties which you can use to define these all entities, right? So all these properties you call them as attributes. So your next step is going to be identifying all the attributes for the respective entities. So next step I'm writing as identify all attributes. Now remember that when we were discussing about attributes, we understood that there were different types of attributes. Few of them were single, the other one had multiple values, some were atomic, some were composite. So there are different types of attributes, right? So to represent each attribute, we follow some convention. Like we were underlining the primary key, then we had some multiple ellipse structure for multi-valued attributes. So there are some conventions which we need to follow. So to accommodate that particular thing, the next step will be to identify types of attribute. So we should have an idea like what is the type of each attribute we have considered. So next step I'm writing as identify type of attributes. Now, okay, now you have entities, you have their attributes. So what's the next thing which comes to your mind? It's about association between entities, right? If there is a system, if there is a scenario, you have an idea like what are the things going to happen, how are the things going to interact with each other. For example, if you have a school system, so you know that there will be some entity known as student which will be enrolled in some entity known as course. So you need to have idea about the relationships. So the fourth step will be identifying relationships. Identify relationships. Okay, now till now it's fine that we have entities, attributes, relationships. Now what next? So remember we discussed something known as relationship constraints. We spoke that there is something called as total participation or partial participation. Then also there's something known as mapping cardinality. So you need to define the constraints or you need to understand about the constraint and you need to represent them in the diagram. So the next step would be to identify the relationship constraints. So I'm writing as identify Now we are ready with everything which we need to draw the entity relationship diagram. So the final step will be draw. Like we need to actually use pen and paper and draw it. So I think this is I think we're clear with the map. Like we're going to follow these 6 steps one by one, and then we're going to draw any diagram for any given system. So to understand this topic in detail, let us take an example and try drawing a diagram for it. So let us talk about banking system. Now, what do I mean by banking system? Can you imagine, like, if you go to a bank, you are a customer, then there are some employees, you go and talk them, you ask them that you need to deposit your money in an account, or you can go and take some loan, you can repay the loan in form of payments. So there is a system, and let us analyze that system and let us try to draw an AR diagram for that. So to begin with, first step, let us identify all the entities present. So I have listed some entities, like 6 entities here. I have considered branch. Like if there is a bank, there is supposed to be a branch, right? In some city or some district somewhere. So then one more thing would be customer. Like if you go to bank, you are the customer. So bank needs to have a detail of their customers about their phone number, contacts, their history, and everything. Then there are some employees who work in bank. So we need to have details of those employees. Then we have some accounts. Now, what are the types of accounts we have in bank? We have some savings account, and also we have current account, right? The one which we use. So here we have some current account and some savings account. So what do we do here in representing? If you remember, we were using is a relationship like specialization or generalizations to represent this kind of state. So we'll take this into account while drawing. Then there is something known as loan, like you request for some amount for loan. Then you have payment, like we discussed this in an example. We have payment, it is a weak entity, and it is dependent upon this loan. So we have discussed all these things before. So considering this 6 entities, let us draw a diagram. I'm not complicating the system, but let us keep it simple and consider the 6 entities to draw a diagram. So our first step was identifying all the entities. Now that all the entities are identified, let us take each entity one by one and figure out what are the attributes which we want and what are the properties which we want to consider while drawing the diagram. So let's begin with branch. Now, talking about branch, let me draw it. My convention says I have to draw entities in rectangle. So branch. What are the things we can imagine for branch? A branch can have some name, right? Some name is there. Some branch ID, I can say, uniquely identify. Now, note that this branch ID is going to be some unique key to identify the branch. So we are calling it as primary key. So let's underline it. Like this is our convention, right? We used to underline the primary key. Now, what else can we have in branch? We can have address of the branch. So then in address, what do you store? City. Then you store about the country. I think it's clear that address is a composite component. That's why I stored it like this, and I mentioned its part like this. So, what else can a branch have? A branch has some of its liabilities and some of its assets, right? So, as we know that there are many liabilities and there are many assets, so it is a multi-valued attribute. So, let us represent it in form of we need to have concentric ellipse for representing multi-valued attribute. So, some assets are there and some liabilities are there. Both of these are multi-valued attributes. Let's move ahead and talk about our next entity, which is customer. Now, what are the things we can have for customer? Let us start drawing. Let us write customer in a rectangle. Customer. Okay. First, and let's start with primary key. So I'll have customer ID as a primary key for this customer. Customer ID. Now, what else can I have? I can have name for this customer. So I'm writing name. Now, there will be some address for this customer. Now, as address is a composite component, let me divide it into city and state, city and country, let's say. I can further divide, but I'm just considering two subparts now. Now, customer can have some date of birth. So now, if I'm having access to date of birth, it is easy for me to calculate age, right? So I'm having a derived attribute as age. Now, a customer can have contact numbers, like multiple contact numbers. So I'm making it as a customer is having. I think that's it we have for the customer, and we're ready with all the attributes of customer, and we have identified the type. Like this is the primary key. We should underline the primary key. Then this is name, which is a simple attribute, atomic, single valued. Then here we're talking about the first name, let's say, or we're just talking about the full name. We're not treating it as a composite component, and we're not breaking it into three parts or so. Then we have something known as address. Address, we're saying it is an composite attribute. So that's why we are mentioning its subparts and sub like attributes and like this in this way. Then we are storing about the date of birth. If we know the date of birth, it's easy to calculate age. That's why age is your derived attribute, and then contacts is a multi-valued attribute. Now we understood about the types of attribute for customer, and we listed all the attributes. So let's move ahead and let's talk about the next entity, which is employee. So for an employee, let's start drawing. Let's begin with the primary key. Let's have employee ID as our primary key. So EMPID. Since it is a primary key, let us underline it. Now employee will be having some name, single valued attribute. So one employee can have one name, right? Then again, address, personal details, address. Again, I'm breaking it into city and country. Now, each employee has some joining date, right? So I can have joining date. Now, joining date is a single valued attribute, but now if you have access to joining date, you also have access to current date, right? You can easily calculate years of service, like how long is the employee working. So our years of service will be an derived attribute. So years of service. Then each employee will have some salary. These are the details I'm storing about the employee. Now let us move ahead, but I think we'll discuss about other entities in the next video, because yeah, let's discuss about that.